Soil texture is a qualitative classification tool used in both the field and laboratory to determine classes for agricultural soils based on their physical texture. The classes are distinguished in the field by the textural feel, which can be further clarified by separating the relative proportions of sand, silt and clay using grading sieves, the particle size distribution. The class is then used to determine crop suitability and to approximate the soil's responses to environmental and management conditions such as drought or calcium requirements. A qualitative rather than a quantitative tool, it is a fast, simple and effective means to assess a soil's physical characteristics. Although the U.S.D.A. system uses 12 classes while the U.K.A.D.A.S. uses just 11, the systems are mutually compatible as shown in the combined soil textural triangle below. Field assessment using a hand texture chart. Hand analysis, while an arbitrary technique, is an extremely simple and effective means to rapidly assess and classify a soil's physical condition. Correctly executed, the procedure allows for rapid and frequent assessment of soil characteristics with little or no equipment. It is thus an extremely useful tool for identifying spatial variation both within and between plots as well as identifying progressive changes and boundaries between soil classes and orders. The method involves taking a small sample of soil, sufficient to roll into a ball of approximately 2.5 cm diameter, from just below the surface. Using a small drop of water or spit, the sample is then moistened to the sticky point. The ball is then molded to determine its workability and its class according to the steps in the chart opposite. Soil separates. Soil separates are specific ranges of particle sizes. In the United States, the smallest particles are clay particles and are classified by the U.S.D.A. as having diameters of less than 0.002 mm. The next smallest particles are silt particles and have diameters between 0.002 mm and 0.05 mm. The largest particles are sand particles and are larger than 0.05 mm in diameter. Furthermore, large sand particles can be described as coarse, intermediate as medium, and the smaller as fine. Other countries have their own particle size classifications. Soil texture classification. Soil textures are classified by the fractions of each soil separate present in a soil. Classifications are typically named for the primary constituent particle size or a combination of the most abundant particle sizes, for example sandy clay, or silty clay. A fourth term, loam, is used to describe a roughly equal concentration of sand, silt, and clay, and lends to the naming of even more classifications, for example clay loam, or silt loam. In the United States, 12 major soil texture classifications are defined by the U.S.D.A. Determining the soil textures is often aided with the use of a soil texture triangle. History of classification. The first classification, the International System, was first proposed by Albert Atterberg, and was based on his studies in southern Sweden. Atterberg chose 20.25 m for the upper limit of silt fraction because particles smaller than that size were not visible to the naked eye. The suspension could be coagulated by salts, capillary rise within 24 hours was most rapid in this fraction, and the pores between compacted particles were so small as to prevent the entry of root hairs. Commission 1 of the International Society of Soil Science recommended its use at the first International Congress of Soil Science in Washington in 1927. Australia adopted this system and according to Marshall its equal logarithmic intervals are an attractive feature worth maintaining. The U.S.D.A. adopted its own system in 1938, and the FAO used the U.S.D.A. system in the FAO UNESCO World Soil Map and recommended its use. See also, soil color, soil horizon, soil type. References. Soil texture, by B. Brown, University of Florida, Institute of Food and Agricultural Sciences. Atterberg et die Rational Classification der Sandunkies. Chemikazeitung 29, 195-198. Davis R.O.E., Bennett H. Grouping of soils on the basis of mechanical analysis. United States Department of Agriculture Departmental Circulation No. 419. Marshall T.J. Mechanical Composition of Soil in Relation to Field Descriptions of Texture. Council for Scientific and Industrial Research, Bulletin No. 224, Melbourne. Prescott J.A., Taylor J.K., Marshall T.J. The relationship between the mechanical composition of the soil and the estimate of texture in the field. Transactions of the First Commission of the International Society of Soil Science 1, 143 Euro 153. Rowdy Soil Science. Methods and Application, Longman Scientific and Technical, 350 pages, 1, 2 Good J.A. A simplified textural classification diagram. Canadian Journal of Soil Science 38, 54 Euro 55. Whitney M. The Use of Soils East of the Great Plains Region. United States Department of Agriculture Bureau of Soils Bulletin No. 78.